Ladies and gentlemen, welcome to the main event. Let's get ready to rumble!
Y'all ready for this?
From the sieve analysis, we are able to grade our soil into categories. The classification of the soil is found by using the particle distribution graph. From this gradation, we have the information about our soil particles to help decide their uses. Much of our soil is classified as a clay from this test. We achieved a large amount of fine aggregate, which is ideal for the berm.
The liquid limit test shows us the boundary between liquid and plastic soil. We obtained the liquid limit, which is distinguishing the moisture content where the soil changes from plastic to liquid. The plastic limit shows the water content at which the soil ceases to be plastic and becomes a semi-plastic solid. By calculating the liquid limit and plastic limit, we can deduce whether our sample is clay or silt and its corresponding percentage plasticity. The results from the plastic limit test told us whether or not the soil had a high or low plasticity value. In our case, this was a high plasticity, which we find extremely desirable for our berm design. We want our berm to hold together well, and high plasticity helps this, as our clay soil will be able to bind together. The aim of the Proctor test is to determine the relationship between the moisture content and the density of the soils compacted in a mould of a given size with a 2.5 kg rammer dropped from a 300 mm height to compact it. California bearing ratio test is a penetration test meant for the evaluation of the subgrade strength of soil. It is the ratio of force per unit area required to penetrate a soil mass with standard circular pistons to that required for the corresponding penetration of a standard material.
Permeability is a soil property indicating the ease with which water will flow through soil. Permeability depends on the following factors: the size of soil grains, the properties of pore fluids, the void ratio of the soil, the shape and arrangement of pores, the degree of saturation.
Purpose of the permeability test. Determine the permeability K of soils by appropriate test methods. Permeability is necessary for the calculation of seepage through earth dams or under sheet pile walls, the calculation of the seepage rate from waste to storage facilities, and the calculation of the rate of settlement of clay soil deposits.
In the moisture condition value test, the minimum compacted effort required to produce near full compaction of a soil is determined. This is an image of the apparatus used for our LCV test in the lab.
Design ideas. The berm should try to fit into its surroundings in the area. The berm should aim not to just be a large pronounced hump in the field. By gently sloping the outer surface of a berm, it is incorporated into the landscape that is already there. A toe at the bottom of one end of a berm in a concave shape will generally complement a convex shape at the top of the berm. A shallow slope of perhaps 5:1 would be ideal here in this respect. Plants and shrubbery can also be used to bind the soil together and give the soil a greater strength in the berm. It is essential that the layers of the berm be organised correctly within the berm, so that it can achieve a high strength and be able to withstand any challenges which the berm may face. The berm can be constructed with mainly clay or any other impermeable soil which has a good strength and bearing capacity. Our clay soil, we feel, can definitely be used to form a design using a method similar to this. If there is not a filter incorporated into the design, the water seepage will cause piping, which will inevitably lead to the failure of the earth dam. The purpose of the filter layers is to allow water to seep freely from the core while preventing any soil particles from passing. When seepage starts, material from the soil is washed into the filter. However, the coarser material in the soil gets trapped by the finer material in the filter, and progressively finer and finer material is trapped behind this. Thus, the material washing out of the soil contributes to the filtering action. The berm will be covered by topsoil, which will allow the growth of vegetation to add an aesthetic value. We decided to plant a think hedge around the perimeter of the berm at ground level so it would blend in with the surrounding woods. In the construction of the berm, there are areas that need to be looked at. The construction of the berm needs to be performed under strict construction health and safety specifications. Everybody who works on or enters the site must possess a safe pass. All visitors to site must wear high visibility vests, hard hat and appropriate footwear. All operators of machines and vehicles in the areas of both excavating and finishing on the site must have the qualifications to operate these machines. There must be appropriate hoarding and signage around the site so that access to the site is limited and monitored by site personnel. We believe that a water safety plan should be put into place also on this project, with all staff required to take a foundation level water safety course. It's obvious from the size of the machines on the previous slide that there are dangers involved with these machines. The large swing of the excavation machine is hazardous clearly, for example. For all of the reasons mentioned in this area, it is recommended that a health and safety manager be incorporated into the project plan to oversee all works carried out on site. Our permeability test did not work to our desire, and for that reason our results were incorrect. More research should have been done on the testing procedures and what their results actually meant. Should have given additional attention towards the actual design of the berm, for example its seepage, compaction and settlement. We should have managed our time better. We felt we didn't use our time wisely in the labs as we didn't fully understand the task at hand and the amount of work involved in the project.
Y'all ready for this?